welcome again to Let's Talk Advanced Chemistry, Chemistry 2 with Pastor Dan. Happy April Fool's Day. It's my son's birthday. There's no April Fools here. We're going to do electron configuration. We did this last year, so if you're really having problems with these, go back in the Chem 1. The videos there, usually around, we'll talk about atom theory, so when we talk about electron emissions, right after that, electron configuration and quantum numbers, we'll be doing that there. Electron configurations are defined as, means to determine the placement of every electron in an atom. And we're going to do that by orbital, number of electrons and number of suborbitals. And remember, there are 5 orbitals. There is the S, and there's 2 electrons in there, 1 suborbital. P, 6 electrons in, 3 suborbitals. D, 10 electrons, 5 suborbitals. And F, 14 electrons in sub. Now, how do we get the number of suborbitals? Remember, there's 2 electrons in each suborbital. They spin in opposite directions. So 2 divided by 2, there's 1. 6 divided by 2 is 3. 10 divided by 2 is 5. 14 divided by 2, that's 7. All right. Now, to set this up, we're going to take this periodic chart here. And remember, if you can get one for this or take a screenshot of the final thing I have over there so we can look at it. But we're going to rearrange this slightly, make some marks on it to help us out. We identify by energy level and orbitals. So what we're going to do is take our chart, move helium next to hydrogen, so that these two are grouped together. Then we're going to put brackets. These are identifying our orbitals. The first 2 columns are the S, the middle 10 are the D, the last 6 are the P, and the bottom 2 are the F. Now we're going to put 2 lines down. Remember when we did electron configurations, we go into the D, you drop down in energy level, get through D, you're going to go back up because of stability. And then we're going to have to number them. We have 1, 2, 3, 4, 5, 6, 7 for energy levels. For F, it's 4 and 5 because they go off that 6D1 and 5D1 from there. All right, so let's try an easy one. Sodium right here. Remember, we moved helium over here. So hydrogen, helium, 1s2. Lithium, beryllium, 2s2. And then 2p6, boron through neon. Sodium's the last one right here, so that's 3s1. That's our configuration. Next, we're going to do silver. Silver's way down here. So beginning, hydrogen, helium, 1s2. Lithium, beryllium, 2s2. Boron through neon, 2p6. Sodium, magnesium, 3s2. Aluminum through argon, 3p6. Potassium, calcium, 4s2. Hit the line, we're going to drop down. Scandium through zinc, 3d10. Hit gallium, I'm going to go back up. Gallium through krypton, 4p6. Rubidium, strontium, 5s2. Iridium, cadmium, drop down, 4d10. Oh, we're going to stop here at silver. We're going to get the count, 4d9. Right there. All right, now the last one on this page. We're going to do lead. Lead's all the way over here. We're going to go all the way through the D's, and they're going to get these P's. So again, beginning, hydrogen, helium, 1s2. Lithium, beryllium, 2s2. Boron through neon, 2p6. Sodium, magnesium, 3s2. Aluminum through argon, 3p6. Potassium, calcium, 4s2. Scandium through zinc, 3d10. Gallium through krypton, 5 p. No, 1, 2, 3, 4. That's right, 1, 2, 3. Yeah, 4p6. Sorry about that. Rubidium, strontium, 5s2. Iridium through cadmium, 4d10. Indium through xenon, 5p6. Cesium, barium, 6s2. Lanthanum, 6d1. No, 5d1. Now we're going to drop down here. When we drop down, we're going to go cerium through luteum, 4f14. We come back up, cross the 5d1 out, 5d10, lanthanum to mercury, and then titanium and lead, 6p2. That's our configuration. Now, if you want to check, you add up all these numbers, and it should equal 82 because the number of protons and the number of electrons are always the same. Again, if these are problems for you, go back to Chem 1, watch the videos on electron configuration there. All right, now, We also have to talk about shortcut method. Shortcut method, we're going to take the last noble gas before that element. So let's do the long method for Rutherfordium. All beginning, 1s2, 2s2, 2p6. 3s2, 3p6. 4s2, drop down, 3d10, back up, 4p6. 5s2, drop down, 4d10, back up, 5p6. 6s2, drop down, 5d1, drop down again, 4f14, all the way cross out, cross 5d1 out, 5d10, 6p6. 7s2, 6d1, drop down, thorium through lawrencium, 6,5f14, cross 6s2 off, and we get
6D1.
6d2. Now, I said we take the last noble gas before that. Last noble gas before Rutherfordium is radon. So we take a radon, 222 over 86, 7s2, 6d1, 5f14, crossed out, 5d1, 6d1, 62. And so basically we're going to take from all of this right here, up to 7s2, include that in Rn 22286. We get that right there. That's a shortcut method. All right, and again, you can check that as well. 86 plus 2 plus 14 plus 2, that's 104 electrons. All right, now the other way to do this is quantum numbers. Now we're going to convert the last configuration, the one that makes it different from each element, into 4 quantum numbers. Those quantum numbers are energy level, orbital, suborbital, and spin. Now, remember we talked about the hotel room, the different rooms, people checking in, the different wings of the hotel, the different floors. Floors are energy level, orbitals are the wings, the suborbitals are the rooms, and the spin, do you have to stand up or have to stand on your head? The first one and then the second one in the room. So let's try sodium. We already done that one. We did that was 3s1. So the energy level is 3, so it's on the 3rd floor. S, remember we said that we're going to make S0, P1, D2, F3. So since it's an S, L is 0. Now, we have that set up. We're going to go from negative L to positive L. So negative 0, 0 for S, for P, negative 1, 0, 1 for P, negative 2, negative 1, 0, 1, 2 for D. For F, it's negative 3, negative 2, negative 1, 0, 1, 2, 3. Those are the suborbitals. Those are the rooms. We're dealing with S, so we're with this one right here. And we're checking 1 electron in. Now, what room is that one in? It's 0. It's the only option we have, so M sub L is 0. Is it the first one in or the second one in? First one, it's happy, it's by itself. Second one, he's not happy, he has to stand on his head. It's plus 1/2, he's happy. All right, for silver, we already said that was 4d9. So energy level, what floor are we on? We're on the 4. Now we're in D wing, we're in the orbital D. Remember we said D is 2. There are 5 rooms in that orbital, 5 suborbitals. So it goes from negative 2 to positive 2. We're checking in 9 electrons. So 1, 2, 3, 4, 5. Go back to beginning 6, 7, 8, 9. So that last electron is right there. That's in 1. So M sub L is 1. And is it the first one in, the second one? It's the second one in. He's on his head. He's not happy. Negative 1/2 for M sub S. Has to do with the spin, orientation of the spin. All right. Last one here we did for lead 6p2, 610 plus 1/2. All right. Try this one on your own. The long, the short, and the quantum numbers for Einsteinium. Okay? Take your time, check it out. Any questions, let me know, ltswpd@gmail.com. Also like, share, subscribe. Any questions, comment, okay? Ready? Here's the answers right there. All right, that's it. Not too bad. Take care. God bless.